我们开始 S2.6 的编会。首先，我热诚地欢迎。
Okay, let's start our session of S2.6. I would like to welcome all the guests and all the speakers to attend the 25th anniversary of International Center of Bamboo and Rattan, and also the second edition of the Global Bamboo and Rattan Congress. Today, the afternoon's topic is the cultivation and sustainable development of bamboo and rattan resources. We have Mr. Fan Shaohui from the International Center for Bamboo and Rattan Center, and Mr. Zheng Shan from the Fujian Forestry University, Mr. Chen Shuangyuan from the Academy of Forestry, and Mr. Liu Guanglu from International Center for Bamboo and Rattan, and Mr. Shriti Saban from the India Bamboo Association, and also Pen Chao from the Hunan Provincial Forestry Academy. There are two friendly heads up. We have altogether 100 minutes. For time interest, for all the speakers, please refrain your presentation within 13 to 15 minutes. And during the conference, we will not have a discussion. If you have any discussions, if you have any questions, you can take down your questions and reach out for speakers afterwards. First of all, I will introduce my presentation. And we would like to invite Mr. Zheng Yuishan to get prepared for your presentation after me. And my topic would be the cultivation technology of a bamboo forest for increasing carbon sink. And I'm from the International Center for Bamboo and Rattan. I would like to break down my presentation into three parts. The first is background, and second, I will talk about the technology and also suggestions. So first of all, I would like to introduce the background of this technology. We know that human behavior have caused global warming from 2011 to 2020. The surface temperature have risen from by 1.09 degrees centigrade. And the average temperature from 1950 to 2019, China's temperature raised by 0.24 degrees centigrade every 10 years.
是造成气候变化的主要原因。
According to ICPP, the human activities are the main cause of the climate change. And in September 2022, the President Xi have announced China's carbon neutrality on the General Assembly of its 75th UN Assembly. So in this background, the carbon peak and carbon neutrality ambition, it's very important for us to find out the solution. And also one of the most important technologies is the US. So in the top level design, our forestry and grassland system can design the major behavior, major activity or action plan of carbon sequence or carbon sink. So it means that in the carbon neutrality equation, the carbon emission equals the carbon sequence and carbon sink, and the absorption of natural system. So for us, our major work is the eco-carbon sink. Before that, we talk about carbon sink through forestation and to absorb the CO2 in the atmosphere, while ecological carbon sink has expanded the traditional idea of carbon sink and also increased the grassland, wetland, and ocean in the absorption of the CO2. In the global design of carbon sink and carbon neutrality, forests have very important role in help us realizing our carbon emission, carbon ambition. In March this year, President Xi made important remarks that forestry is the important thing for both water, reservoir of water, for finance as well as for food and also for carbon sink. And the forest ecosystem is a huge carbon absorption, while the total carbon reserve storage in China is 79.2 billion tons, and the forest accounts for 30.8 billion tons, accounting for 69%. It has different ability or capacity in reserve. And we find out in different types of forest, there are different types of carbon sink and carbon storage ability. It means that bamboo are a really important system for carbon sink and carbon storage, and the bamboo grows fast and has strong carbon fixation capacity. Due to its plant attribute, the vegetation will not be affected after harvest. So it plays a very important role in our carbon peak and carbon neutrality national strategy. And next, I would like to introduce the carbon fixation of bamboo forest. There are two ways for us to increase the bamboo forest carbon storage. First one, we want to increase the scale of bamboo forest resources. From the 19th survey, we can find out that the total area of a bamboo forest is around 6.412 million hectares, accounting for 2.91% of China's forest area. According to previous surveys, the area of bamboo are increasing with an annual 3%. The increasing area of bamboo forest will also increase the carbon sink capacity in China. And the second way is to improve the quality of existing bamboo forest and increase the carbon sink capacity. We find out the forest after operation, the bamboo forest after operation will have a much higher efficiency in carbon sink. And the bamboo forest with regular operate will be much more efficient in attracting carbon sink. So it's very important to maintain the healthy growth of the bamboo forest and improve the carbon fixation capacity of the bamboo forest. According to current data and the material, they well-operated bamboo forests accounted for 15 to 20%, while the 50% of the bamboo forests are poorly operated. So according to good standards, there will be about 100% to 150% of the increase of carbon sink for bamboo forest, and which account for about 5.2 to 6.5% of the total carbon sink of a forest. That is a remarkable increase. Next, I would like to introduce the important technology used for increasing bamboo forest. First one, we want to regulate the stand structure. The density regulation is closely related with the geographic location, forest soil condition, forest condition, etc. So we find out if we had a better density, the bamboo types like dendrock and pasque and also philosol interest will also increase in terms of the density and humidity. If we calculate the commercial forest of the density of 1,800 species per hectare, as an example, let's take the Qinggangshan as an example. The incremental of carbon sink will increase about 4.85 million yuan. Second, we want to change the age. We want to conduct age regulation. The bamboo forest with different age group will also have the impact on the carbon sink ability. For the well-operated bamboo, we should keep a certain proportion of long-term bamboo. So let's take a look at the neo-stenochemical ovens. The new bamboos will have a higher ability of carbon sink, while the age is 1 to 1.5 years old. And the next technology is individual size regulation. The size of the bamboo forest will also have the impact on the carbon sink capacity. The diameter at the breast height of the hot-headed mother bamboo should be around 4 centimeters. And the stand with 10 centimeter to 12 centimeter DHB would have the best carbon sink ability. And firstly is about the regulation of a tree species composition. The bamboo broadleaf or firmest model is conducive to increasing the total amount of carbon sink. And economic type, we have different types. We have it's best if the economic type, economic ecological type, and the ecological type is less than 20%, 20%, and 30% respectively. And the next solution is the forest land nutrition regulation. Different land may have a different impact on the carbon sink ability. So the most important fertilizer is organic fertilizer. We find out that the fertilization of philosophies pupae under different fertilization treatment will increase the carbon storage in the vegetation layer.
林分管理应以少劳动为基本原则。
So we should have less interference and the distributes and a reasonable fertilization method and frequency should be selected. And the third method is to improve the optimization of the operation. Appropriate fertilization will also increase the carbon sink ability. They compare with traditional management model, the annual fixed CO2 amount of mossel bamboo forest under the management of a mossel bamboo with overlapping, alternation, and intermittent conventional management has increased by 1.5 times. So we have these technological points. The first is large density, and the second is business technology. The next is about fertilization and late harvesting and less reclamation.
实施地场林质量提升工程，提高竹林碳汇的增汇潜力。第二是完善健全竹林碳汇交易平台，提升碳汇竹林经营效益。
Efficiency and the tax market from this exchange market, is it possible that we can get the benefit of our work? And also we need to promote the replacement of material with bamboo to achieve the emission reduction effect. At this conference, Chinese government, in collaboration with the international organization, has the exchanges on replacing plastic with bamboo. And also we need to improve the measurement, monitoring, certification of bamboo products, zinc. And also we need to innovate the management model of the whole bamboo chain, industrial chain. These are the results and some achievements of the research of bamboo. That concludes my presentation. Thank you very much. Next, we would like to invite our second speaker from Fujian Agriculture and Forestry University, Professor Zheng Shang. He will talk about the research of planting bamboo in the sand in the coastal areas. Good afternoon, moderator. Can you hear me? Yes, we can. Good afternoon, moderator. Good afternoon, colleagues. Or good morning or good evening. This afternoon, I would like to take this opportunity to share with you the result of our research of our team over the past 20 years, the bamboo introduction in the coastal areas. We know that the Coastal Protection Forestry Project is one of 6 major projects proposed in China's plan and one of the 8 major forestry projects in Fujian province. The coastal shelter belt in the southeast coast is more than 7,000 kilometers. For a long time, casuarina plantations generally have a single species, and it is very difficult to renew. Casuarina equisetifolia was planted in 1950s. Now it is time to renew these trees. It is very imperative. As we know, bamboos are an ideal choice. Bamboo selective cutting operation and sustainable management with high economic benefit, and also bamboo has strong performance. After 20 years of studies, we have introduced 111 bamboo species in bare ground in the coastal area, and also the planted and the current or existing trees. We have studied techniques for cultivating productive forests, ecosystem research, etc. Well, we have studied its growth status, for example, the survival rate, the growth rate, high growth pattern, and biomass. We also studied the number of shoots and standing plants, the bamboo shoot period, the growth mathematical models, and the biomass. In terms of the bamboo forest ecosystem, we have studied biomass, moisture dynamics, nutrient properties, nutrient cycling, etc. In terms of the biomass, we studied the bamboo growth condition, its distribution, and moisture dynamics. We have studied water penetration, etc., the holding capacity of the forest stands, and the distribution of nutrient content in bamboo. In terms of the resistance mechanisms of windproof performance, we know that in the sand of the coastal areas, it is we have salt resistance mechanism, drought resistant mechanism, and wind resistant performance. In terms of the technical system for cultivating productive forests, we have studied fertilization effect, decision analysis, construction technology, including the sand afforestation technology, and also we studied the operation management. In our 20 years of bamboo introduction in coastal sandy land, we have identified 38 species that are suitable for all sites. 15 species are suitable for bare ground. 46 species are suitable for underground. 45 species are suitable to grow under the existing trees. First, bamboo species that are suitable for all kinds of surfaces. Those bamboos can be planted on the bare land and the existing trees, etc. These are two species that can be planted. These are the two of the very good species among the 16 species. Bambusa, Orundinacea, they can keep the soil and also resistant to wind. These two species are very adaptive to the environment, and these two there are many the other species, mixed species, mixed type. And this minor bamboo species, they are evergreen bamboos. And this bamboo species are in the subtropical area. Also, we have these two species for ornamental purpose. These two the same. Also, we have this ornamental bamboos. These are for the landscape. 15 bamboo species are suitable for bare ground. As follows. This is for ornamental bamboo, Indo-Salsa, number 11, number 1. Different bamboo species. These are 14.6 species enter the forest. We know that Plablastus amorus was planted under the evergreen trees. They are growing very well. And also, we have these 2 species, 2 more introduced species, and also have 45 species under the forest. These are the pictures of this bamboo species. Bambusa, for instance. Also, we have some unsuccessful introduction of bamboo species. For instance, this mossel bamboo cannot grow very well in coastal sand areas. In terms of its adaptability, these are their performance variance. Those suitable species grow very well in the coastal sandy areas and show good adaptability. Well, the biological, ecological, or biological features of bamboos are different. They have differences in terms of their growth. Well, most of the introduced bamboos can grow normally in coastal sands, but their shoot production, shoot length, and the number of bamboo stems vary significantly. The number of shoots and bamboo stems are maintaining at a high level, even exceeding the original level, and the shoot period is longer. The bamboo species with a poor growth performance basically can only survive on sandy areas. They are unable to adapt to the coastal sand ecology. These are the shoot growth surveys. Study on bamboo forest ecosystem, we introduced biomass, including monoculture, 1-year-old, 2-year-old, and forest stand. We also studied the moisture dynamic, including retention and runoff volume, water penetration, soil moisture content, and water retention. We also studied the nutrient characteristics, including the apoptosis, its occurrence, nutrient content. Also, we studied the nutrient cycling, including decomposition, etc. Soil water content changes are influenced by rainfall, with 2 peaks occurring throughout the year. Soil oil content in woodlands below 20 centimeters increase with increasing soil depth. The water storage in the sand is dominated by 1 to 40 cm soil depth. These are our study pictures of our studies. Number 6, mechanism of drought, salt, and wind resistance. We have done the water and the salt stress test. We studied and analyzed the changes inside the bamboo and to select the suitable area and its features. In terms of the wind resistance of bamboo, it is related to the second half of the column should be better or longer than the first half. Also, we have done some assessment of the wind resistance of the bamboo. This is the first year. The bamboo grows very well after planting. The second year, vigorous growth and efficiency. The third year, enhanced protection effectiveness. And the fourth year, very stable protection effectiveness. In our 20 years of study, we have studied the impact under the influence of Typhoon Pro, its impact on the bamboos. You can see that some bamboos are destroyed. The typhoon has caused severe consequences, damage to the forest. All the top of the trees are destroyed, damaged. Well, you can see the impact of the typhoon on the bamboos, very minor damage. Therefore, bamboo forest is very effective against the wind. Number 7, cultivation technology of a high-yield bamboo forest. We have studied all the system profitable bamboo forest in coastal sandy areas cultivation technology system, which includes all these different components. It is very complicated. We have a very extensive study.
This project actually has been promoted in many areas in Fujian, including places like Dongshan, Putian, Jinjiang, Changle. It has a really obvious effect on the increase of yield. And it has a wide application prospect. These are the pictures from different sites, for example, from in Putian, in Zhangpu, and Jinjiang and Changle. And also the forest on different places. Thank you. That's so much for my presentation. Thank you for your listening. And also, I'd like to thank the host. Thank you, Mr. Zheng, for your wonderful presentation. The forestry in the coastal area actually is also a very important innovation. So the application of a forest are also expanded and also have a better use of the ecological function of the forest. Next, we would like to invite Mr. Chen Shuangling from the researcher from the Chinese Academy of Forestry to give us a presentation. Hello, everyone. Today, I would like to introduce the theory and practice of remediation of the contaminated soil in bamboo shoot forest. I have 4 contents: pollution by organic. The first is organic fertilizer and pollution from the weed killer or the herbicide. We use different types of organic fertilizer, pesticide, including organic chloride and organic. We also have different other types of pesticide. And about the residue, there are a huge amount of residue which will have the biggest residue will reach the national standards. And about the feature of the pollution, it is scattered. It's quite scattered. With some area are more polluted, while it has a spot pollution. And for OPP, the pollution is more difficult to treat. And about the soil remediation, we have different methods, including chemical method, physical method, and biomethod. We have done we have done the biodegradation agent or solution. We can produce an agent after cultivation and the fermentation. And also, that kind of a solution can be used to degrade the pesticide. The result is quite effective. After using for 15 years, the dissolve rate of the organic fertilizer or pesticide is up to 85% and also 60%. And it will also increase the vitality or dynamics of the rhizome, and the rest intensity of soil will also be increased. The second is herbicide. Mostly we use with paraquat, but it was not now forbidden. It is now forbidden for use now, and then mostly we use the glyphosate, and the glyphosate will easily lose its vitality in the soil. And after raindrop, it will be leached and dissolved in the underground water, and it will also affect the health. If it is contaminating drinking water, it will also bring harmful impact of the local residents. But we have a lot of bamboo shoot in Zhejiang province. We are using the herbicide to control the underground rhizome of bamboo. The second pollution is heavy metal pollution. This is quite obvious or quite ordinary, common in many forest growing area. In many places, we tested the soil in the forest about the content of lead and zinc, and the content of them is around 16% and 25%, which is respectively, which is quite high. And the content of a heavy metal in the soil is already close to the warning level or standard warning level. And most of them, the average content of heavy metal is within control. The source of heavy metal pollution are diversified, including the mother rock, stress wastewater of the industrial production and chemical used in agricultural production, as well as transportation, and also the organic chemicals used in agricultural production will also cause the pollution, heavy metal pollution. And the rime is the most important organ to absorb heavy metal. Different variety of bamboo have different durability of heavy metal, have different tolerance to different types of heavy metal. And heavy metal will low content of heavy metal will be conducive to the growth of a bamboo, while over content will restrain the bamboo from growing. And for the remediation, we have different methods. The first is about we can change the types of bamboo forest. For those heavily polluted bamboo forest, we can operate them into the landscape, eco-landscape forest, as well as bamboo timber forest. We can use both chemical measures and physical measures. For example, the biorevivification or the biomass carbon or vegetation restoration. We still need further study about the result of vegetation restoration. Another pollution is nitrate pollution. And the nitrate pollution naturally will cause cancer for humans. It's very, very dangerous. There are also wide sources of the nitrate pollution, including the industrial emission, burning of fuels, as well as life waste. And the content of nitrate pollution in the soil is in a upside V shape. And the content of nitrate salt is around 33%. And the heavily fertilized bamboo forest, the content of nitrate salt is around 745 milligrams per kilogram, which is far above the standards of 69% by WHO and FAO. So after our treatment, we can reduce the content of nitrate salt content. Then we can choose the organic fertilizer and biofertilizer to reduce the use of chemical fertilizer. And also, if we are going to use the fertilizer, we need to avoid use them in spring and summer. And also, we want to use inhibitor for nitrate fertilizer. We are also going to start another research topic, which is the plastic pollution. And plastic pollution is really a headache for us because we have a lot of microplastic and nanoplastic. They have a lot of plastic pollution, and there are less research into that. We can look at the features of the soil pollution, including the types, the quantity, the scale, and the source. And also we can do research into the bamboo pollution, which organ of the bamboo are polluted, and the transportation mechanism from soil polluted and plastic polluted soil into bamboo. And we also need research into the restoration. That's so much for my presentation about the pollution and the restoration theory and practices. I believe that is quite important for the safety and sustainability of bamboo shoot industry. Thank you for listening. Thank you, Mr. Chen. Mr. Chen actually have done a really in-depth study into the pollution and the restoration of bamboo shoot because the pesticide and the fertilizer pollution is a really interesting question.
In cultivation of bamboos, we used fertilizers which might be polluting the environment. That is something we need to be aware of. Mr. Chen's research and study is very important for our future practices. Once again, thank you very much, Mr. Chen. Thank you very much. And now we would like to invite Mr. Liu Guanglu, Associate Director from ICBR. We would like to invite Madam Subhana to make a preparation for the afterwards. So now, Liu Guanglu, please.
各位专家，大家好。
Dear experts, good afternoon. My topic is study on sister generation growth. Of rattan in secondary rainforest in Hainan. So these are the contents of my presentation. First, the background. This rattan family, it is distributed in the Asia Pacific subtropical and tropical regions. It is a plant that is dependent to the forest. Currently, we have 631 species, and in China, we have 32. There are two regions, Hainan and Yunnan. They are the two regions for the distribution of rattan. It is rattan industry development. It is an ideal choice for making furniture in 1970s. Since 1970s, rattan furniture industry and international trade has developed rapidly, and it is also providing a tremendous amount of job opportunities. 19% of raw material required by rattan are from wild resources, only 10% from artificial cultivation. China is a major importer of rattan in the world. The shortage of rattan resources and insufficient supply limit the development of rattan trade. Since most of the resources are from the nature, and the theoretical study is very weak, our research has conducted research on cultivation of naturally distributed rattan resources, and our results very conducive to the practice. We started research from three aspects. One is the seeds, and we evaluate the soil seeds. Second is natural renewal of seeding cultivation model. We cultivate the seedlings. Third, natural renewal of rattan growth promotion model so that they can grow very fast. We select our study site in Hainan, a natural reserve there. This is the location on the map. Here it has distinct the rain seasons and the dry seasons. from May to October with a lot of rainfall. From November to next April is the dry season. This is our technical roadmap. First, we study its seeding, and then we plant the seedling as giving it water, sunshine, and we provide try to come up with the technology for cultivating this bamboo. And then so we studied the regulated behavior to improve its productivity and growth rate. The human interference and human intervention measures are proposed. Thirdly, the main results, the characteristics of soil seeds, seeding numbers, and distribution of rattan. 83% of the area in the region had the soil seeds, so it can ensure the natural growth. The seedling distribution is affected by the parent seedlings, and it is the plot shape distribution. For this kind of rattan, it is distributed in the 4 to 6 meters. This for the seedlings and its relationship with the number of seeds, we can see that it is affected by the environment and the parent seeding. In terms of the environment, it is related to the forest density, etc. And also the yellow rattan and the white rattan, we classified them into different categories or degrees. We'll see the grade 2 yellow rattan and the grade 1 white rattan are very critically affected by the environment. Natural renewal or seeding ex situ cultivation model, we try to simulate natural environment in terms of the moisture of the soil, the light, and the nutrients of the soil. We can see the enhancement in terms of its productivity. Natural renewal of rattan growth promotion model. We have studied the relationship between the rattan growth and environmental factors. We identified the major inhabitant restrictive measures, which are the soil, water, and the slope. Different seedling have different in terms of its adaptivity to the environment. For instance, the white rattan are affected by the soil. The big white rattan is affected by the soil and also the slope. In terms of the height and its diameter, they are affected by different factors. The height is affected by the water. Height is negatively related to the slope, the density of forest, the water volume, and the spacing. And the calm growth is related to pH value. For the yellow rattan, it is positively related to the slope. forest density, the organic matters, moisture in the soil, etc. Also, we have studied the technology for promoting growth of yellow rattan and white rattan, and how can we improve the survival rate of the seedlings. For white rattan, it is growing very well in some soil. And lighting is another key factor for the growth of rattans. When the lighting is about 14 to 15%, the white rattan grows very well. Moisture and fertilizers impact on the growth of rattan. Yellow rattan are suitable for moisture, and white rattan for semi-humid environment. For the fertilizers, different. For yellow rattan, they have different requirement of fertilizers. Based on our research, we can see that through reducing the impurities and by changing the light and the moisture in the soil, and also moderation of the fertilizers are very key for the growth of yellow rattan and white rattan. We improve the rattan resources development is crucial for ecological development and economic development in reducing poverty. Thank you very much. Thank you very much, Mr. Liu. This is the second Global Bamboo and Rattan Congress. Our research subjects include bamboo and rattan. In our presentation, we should have the studies of rattan. Just now, Mr. Liu Guanglu has shared with us the study of growth of rattan, which is a very positive attempt or efforts. Just now, he talked about how rattans can be promoted in terms of this growth through human efforts. This is a very good effort and very good research. We need further studies on this topic and further communications. Our next speaker is Shruti Subana, Secretary and Treasurer, Bamboo Society of India.
林业科学院的彭超研究员做准备，有请苏巴娜女士，谢谢。
A very good afternoon to everybody. What I am going to talk about today is the economic analysis of sustainable bamboo cultivation strategy, specifically for Dendrocalamus toxii. And this is across different treatment regimes in the semi-arid regions of India. So this is a combination of, this is research work done in our lab under Dr. Shyam Vishwanath, and both my lab partner, Dr. Lobina, and I have worked on it. Let me just briefly run through what I'm going to cover in this presentation. So one is, I just thought, let me give an idea about how bamboo cultivation is in India, just to give a context to an international audience. And then, go into more detail on the different stages of the experiments that we've conducted. So this is like a 3-layered theme that we did. One is use of different treatment methods for and how it impacts growth of Bangalore. Then we did an estimation of its biomass and productivity, and finally the economic analysis. And then, of course, what we found, the results discussion, everything. So when we talk about distribution of bamboo in India, we have over about 136 species, and it's mostly the northeastern part of the country where there is greater diversity and also greater concentration of bamboo itself. Certain parts of the central India also do have good bamboo concentration, and we have about a total growing stock of about 80.43 million metric tons. So just to give a context of how bamboos are in India. Specifically, there are these 18 species that have been identified as economically important. Here we primarily talk on the Dendrocalamus toxii, the 11th serial number that has been highlighted. Just about the specific species, it's primarily found in the Western Ghat part of India. So the western coastline of India is where it's found, and it's commonly called as Marihal bamboo there. It's used extensively in furniture by the furniture industry in those parts of India. So let me just come to the whole, experimental setup. So the study was conducted pre-COVID, sometime from 2015 to 17-18. When we started the study, the age of the plantation was 11 years. This was done. So if you see the map below, this was done in the southern part of India. Bangalore is one of the more prominent cities, which is why I've left that. And what you see as the red mark, that's where is the field station where these studies were conducted. So these images just show us, show kind of how we went about the whole experimental setup. So we, had a pit dug around the clump, and different treatments were added around the clump to see how it impacts the growth. So the pit was about 15 to 20 centimeters deep. And other than the different treatments, there was, of course, a control that was kept. So these are the different treatments that were used for the study. So the last T5 was the control, where we did not touch anything at all. We used a combination of a nitrogen phosphorus phosphate. Then there was just biochar. Biochar with the conventional compost. Then we used a combination of these things, NPK and biochar, and then NPK and biochar and compost. So these were the different treatment methods that were used, and we studied how it would impact the growth of bamboo. So when we're talking with the whole, biomass estimation, typically there is destructive sampling that's involved. So around the clump, 5 random clumps are selected. Basically 1 in the center, and 5 somewhere around the edges across the area where the same treatment was done. Now for each of these clumps, 5 culms were taken, and these were used for analysis of biomass. How we go about it is, so these images show us the destructive sampling that was done, and so culms about 15 to 20 centimeter length columns were selected. The green weight, the original green weight, was taken in the field itself. These subsamples were gotten to the lab, where they were dried to see how much moisture content is there in these samples. And then, we extrapolated it to what is the potential biomass and productivity in the actual field conditions. So that was the procedure that was adopted. Now, once we get the biomass itself, now the biomass by itself also translates to better economic returns. So we try to understand how economically beneficial these different treatments are, and whether they are or not. I mean, that's also a question that needs to be answered. So when we do this whole economic analysis, there are two aspects to it. What is the cost that's incurred by the farmer and what he gains from it? So when we are talking about what is the cost incurred, these are like, few that are listed in terms of the labor or initial seedlings that, would be input, or the addition of inputs, depending on what are the inputs that you're looking for, whether it's just NPK or NPK and biochar or, nothing. And other, sometimes one-time investment like irrigation systems, watchmen, the whole fencing, so there is less damage to the crops through wildlife, etc. And when we're talking with respect to the output cost, it's primarily the culp that is sold, and at whatever cost it's sold, that's the profit, or that's the money that the farmer makes. Now, there are like 4 primary parameters that we have studied for the economic analysis. One is the benefit to cost ratio. So benefit to cost ratio is basically, how much you get over how much you give. So anything over 1 is considered as a profit. So I sell something for 2 rupees, I spend 1 rupee, 1 rupee is my profit. So that's how it is. Then there is net present value, which looks at it from a combined. So because bamboo is like a 40-50, depending on the species, it's like a long-term crop. Over a period of time, what is the gains that's internal rate of return is in terms of percentage, how much would somebody make. And equated annual income is, again, because it's a long-term crop, how do I compare it on an annual basis? So equated annual income is what gives you an idea on how much would be the approximate profit on an annual basis over that 40-year period. So this is an idea of very briefly on how it has equated in terms of economic gains for the farmer itself. So, I mean, across all treatments, including the control, it's definitely beneficial, because anything over 1, would be considered as profitable. So across everything, yes, it is beneficial. But what would be more beneficial? So based on what we observed, the first treatment that we used, which is just the use of NPK, that proved to be the most profitable exercise from a farmer's perspective, in terms of how much he would spend to how much he would gain. So you're talking about a 36% gain, or an annual income of close to 2 lakhs. This is per hectare that we're talking about. So close to 2 lakhs is, what they could expect. The next best was NPK with biochar, again, a little over 1.75, 1.8. So these are, broadly the findings that is based on these 5 treatments that we studied during the study period. Now, few things. One is, of course, so one of the critical reasons to study this was to understand the economic benefits and the usability of bamboo cultivation itself to the farmer. So we all talk in terms of the whole sustainable development goals, and how poverty eradication is a potential reason to grow bamboos, how it could be a potential reason. Also, when you're talking about increased productivity, increased biomass, it also translates to increased carbon content that the bamboos would have. So increased carbon sequestration. Again, looking at it from an SDG perspective, the SDG 13 plays a very important role, achieving SDG 13 plays a very important role. So these are, two primary criteria that we were looking at when we tried to do this study. Of course, I've listed how each of these is, how which treatment works better and which treatment is not so good, but overall everything is definitely economically beneficial. Now, one particular point is that I would like to make is that, so we have looked at this study primarily from a bamboo productivity perspective. One potential angle that we are looking at for future studies is whether how it is impacting the soil fertility, how these different treatments are impacting soil fertility. Because at the end of the day, we also say that the economic benefit should not be at the cost of agro ecosystems. So understanding the whole concept of the soil fertility across these treatment systems also becomes important to get a more holistic view, and that is one of the things that we hope and we aim to study in the near future. And yeah, with that I'll just end my talk here, and thank you very much, everybody. Thank you.
Ah, 好的，非常感谢
Thank
Subhana
you, Madam Subhana, for your presentation. You have introduced the different treatment and economic analysis in the semi-dry area in India and a sustainable growing cultivation model. And you talk about the best solution choice. We know that economic sustainability is also the most important consideration in real life. And such kind of research really need the major production farmers and countries to learn from it. And India, I believe, is the biggest place with varieties and also places. They have a high level of cultivation and plantation, which can be referred as a really important reference for both China and the rest of the world. We'd like to thank Madam Susanna again for your presentation. Our last speaker is from the Peng Chao from the Hunan Academy of Forest. Let's invite Mr. Peng Chao. Thank you, moderator. Distinguished guests, I would like to talk about the efficient cultivation and industrial development of Indo-Colo resources used on leaf utilization. First, I would like to introduce about Indo-Calimus bamboo. It is a small bamboo with big leaves and fast-growing period and high yield and productivity. It's located in the Yangtze River basin. There are around 33 species. Sorry to interrupt. Could you show the slides in full screen? It's not yet full screen. If you want to start all over, if you want to start these slides all over. It's not yet.
它那个有换液换印，没换液换印，等于是还是在那打开的状态。
好，现在可以了。
啊，不好意思。
Now it's working.
我做的报告的内容
So my topic is efficient cultivation of and the industrial development of Indo-Caucasus.
包括以下6个部分。
There is 3 contents. The first is a brief introduction about this Indo-Caucasus. It is located in Yangtze River Basin and its southern region. Approximately 33 species have been calculated in this genera, epidemic genera of China.
跟这个国外的几个地方所报道的弱组是不一样的，所以的话
Genera
中国的这个弱组的话是属于特有种，特有的一个属。弱组呢主要是分布在亚热带湿润气候区。然后的话，它主要
It
是
is distributed in the subtropical humid climate region and mainly grows on slopes, valleys,
海拔大概是300到
and the altitude is about 300 meters to 1,600 meters.
在这几个在土壤湿润、
For the Indo-Calamus,
充足，还有
it grows very well
土壤肥沃、
with
良好，同时呢，
a lot of sunshine and a lot of
地区
water.
轻度盐碱地方生长非常良好，
It has strong
还具有一定的这个
adaptability to soil.
目前的这个弱组的利用
Some background. It is widely used. It has some medical value.
常用的
It is used as the antioxidant,
包括这个传
and also it is used
现在目前的话，
to make
主要是在2个点，
some
这个
brushes,
还有一个
and also
包装，还有
it is used for packing. It is used for landscaping.
同时呢，它还有一定的应用价值，在抗氧
It has
抗菌，还有
some a lot of value.
的疗效，
It is also anti-cancer.
还有这个还有
It has
大量的这种
it includes 18 kinds of amino acids. Therefore, in the drinking and in the animal feeds, it is widely used.
仍然是成为一个主流。
Traditional use is still dominant of the Indo-Calamus. Over the past 10 years, the industry is growing very rapidly. It is a sunrise industry, a green industry. These are the processing plants.
现在这个弱组的资源的话，主要的这个原材料来源主要还是
The source of the Indo-Calamus, most of them are wild. However, they are not very well managed.
弱组的这个
Therefore,
数量，
the quality and quantity of Indo-Calamus decreases.
因此的话，基于这个
Therefore,
发展的需求，
with the demand increasing,
上日常
there is a need for the forest, artificial forest. According to the result of our study, we found several issues. One is there are less varieties and the low survival rate and the character instability. Therefore, we need to have a high yield plantation.
现在目前从这个良种的筛选这方面，
We start from a selection of the high quality species. Firstly, the selection of the species based on the needs of the market and the enterprises. We consider the leaf width, the bigger the better. 8 bigger than 8 centimeters is the best, and also rarely have brown hair. The third is without a flax on leaf. These are the qualified leaves.
这个一系列筛选的话，我们
According to, based on our selection, we identified 4
会热组，第二个
Indo-Calamus,
中巴热组，还有我们湖南本地的湖南弱组。
and these are the 4 species we have identified. In real practice, in the management or operation, we want to know the vertical distribution and morphological characteristics of the rhizome. We found that their rhymes are distributed from 0 to 10 centimeters, which is not demanding for the depth of the soil, which means that they can grow very well on host surfaces, and its rhizome biomass is affected by the nutrient in the soil. Mother plant selection. We have made the correlation analysis of mother plant traits and sprouting traits. Mother plant traits have a strong correlation with new traits. We also found a stronger rhizome diameter of the mother plant and more powerful of germination. Therefore, we can select the parent mother plant that is bigger than 6 centimeters. Mother plant treatment. Two treatment. One is cutting stem and growth regulator treatment. Cutting stem treatment. We consider the density and height. We found that 15 centimeters. The result showed that mother plant with 15 centimeters height and a cultivating density of 2 ramies had the best effect. And we use the NAA treatment on rhizome of mother plant, which promote the sprouts rhizome growth. 100 ppm treatment is very good. Quality grading assessment of container ramies. We select RTB and LDR as the dominant grading indicators. While we determine these two indicators, we found that in reality, there are some difficulties in applying these indicators. Therefore, we further analyze and study the indicators. We identified number of the rhizomes and its length. Then divide into 3 grades. One is the rhymes length is bigger than 42, and the number of the rhymes is exceeding 3. Grade 1 and grade 2, we can find that the shoot number is over 88%. Also, the cultivation with rhizomes, 78% of survival rate has been realized by rhizome age, length, planting time, hormone treatment, etc. Based on our study, now in 2 places in Hunan province, we have 2 cultivating demonstration bases. This is a case study of Shangzi County, the construction of plantation, artificial forest management operation in the county. More than 1,300 hectares have been cultivated in recent years. Secondly, natural resources improvement. In the Samzi County, the natural resources of natural forest is about 1,800 hectares distributed in the county and rarely utilized. Approximately 18.05% shoots are 1-year-old individuals. The population structure need to be modified. The local government has invested heavily, and now more than 300 kilometers have been developed. Cultivating mode, we adopt 3 models. One is compound management mode, including we found that these are very effective mode. Also, we explore the slope protection mode and a 4 sides mode. And also the development of the tertiary industry and the plantation is combined with the tourism, and some cultural products have been developed. Now the products have been found good markets in China and also in the neighboring countries, also to Canada, America. More than 14,000 farmers were employed. 12,000 families were left out of poverty. For the industry development, focus will be on the pollution-free deep process to eliminate the negative impact on the environment. And also second direction is extraction of active substance. There are a lot of beneficial compounds in this species which are good for human health, and leaf extracts are antioxidant. For further studies of the past 10 years, we have yet need to develop further the studies, including its growth habit, community structure, carbon fixation, etc. And also second point is high yield plantation management. The management technology, leaf pickup technology, fertilization, this will be better developed. So thirdly, on the improvement of the low-yielding natural forest, we need to study the age structure adjustment and fertilization. Intensive processing technology, we need to pay attention to the food safety, active substance extraction. Food safety is a very serious issue. And also in terms of intelligent equipment, we can develop the equipment on screening leaf, cleaning leaf, heavy metal detection, etc. That concludes my presentation. Thank you very much. Thank you very much. I'd like to thank Mr. Teng Chao for your very interesting and very insightful presentation. Bamboos are valuable resources. Leaves are a very important part of it. Teng Chao just talked about the intergovernmental, the leaf resources and the cultivation of the intergovernmental and its industrialization. His studies or his research has touched upon the traditional value of the intergovernmental and also its combination with the local culture. This presentation is very significant because we know that festival has some flavor. What is the flavor of festival? That is the food, the taste of the food. For Chinese Dragon Boat Festival, the taste of the festival food, zongzi, actually is a taste of the Indo-calamus leaves. Now we have 6 speakers. 6 presentations have been delivered. Our session is within 100 minutes. However, we have extensive discussion, presentation in covering rattan and bamboo. There are some hot topics, such as the technology for carbon sink of bamboo, and also the management of bamboo forest, the cultivation technologies, and also the session covers the proper use of fertilizers and avoid the contamination of the food and the soil, and also the economic analysis. What is the best approach economically so that the technologies are sustainable? Also, our presentation touches upon leaves, the biological features, etc. It covers a wide range of areas. Also, the artificial cultivation and how can bamboos, the rattans grow faster.
But for bamboo and rattan, the research actually should be quite intensive. And for all of this presentation, we have done the exploration and the research from different angles, and we still need much more to study and further discussion. For time and interest, that's so much for this session. I hope we could continue our discussion in other occasions. In the end, I would like to thank the second Global Bamboo and the Rattan Congress organizer for providing such kind of platform for us to talk with each other. I would also like to thank all the speakers this afternoon. Now, so I would like to thank the translators for your wonderful job. And we would also like to thank all the equipment providers for making this online discussion possible. And in the end, I would like to thank all the participants, both from online and offline, and all the speakers, scholars, and audience. Thank you. See you around.